Hey everyone, welcome to my channel. Today we are diving into something truly fascinating that you might have seen in sci-fi movies or even in some eerie photos of nuclear reactors, the mysterious and mesmerizing Cherenkov radiation. You know, that glowing blue light that almost looks like something out of this world. But what exactly is Cherenkov radiation and why does it have that iconic blue glow? Let's break it down together. Alright, what exactly is Cherenkov radiation? In the simple terms, Cherenkov radiation is a type of light that is emitted when a charged particle, like an electron, zoomed through a material like water or glass. Faster than light can travel through that same material. It's almost like the particle is breaking the speed limit in that medium, creating a sort of light boom. But don't worry, it's not breaking any universal speed limits. More on that in a minute. So let's talk about how light works in a different places. In space, or what we call a vacuum, light travels at its maximum speed, which is about 300,000 kilometers per second. Or for those who prefer miles, that's roughly 186,000 miles per second. This is often referred to as the universal speed limit because nothing can go faster than light in a vacuum. But here is the cool part: when light passes through a material like water or glass, it actually slows down. The exact speed depends on the material it's traveling through. For example, in water, light slows down to about 75% on its speed in a vacuum, so it's still pretty fast, but not as fast as it could be in space. Now let's introduce our main character, the charged particle like an electron. When this particle moves through medium like water at a speed greater than the speed of light in that medium, something really interesting happens. The particle is not actually going faster than the speed of the light in space. It's just going faster than light can move through water. Imagine it as a speedboat moving through water, creating waves as it goes. The particle creates a similar effect, but instead of water waves, it's creating a shock wave of light. Here is how it works. As the particle zooms through the medium, it disturbs the local electromagnetic field, causing the atoms in the material to become polarized. This just means the atoms get a bit out of whack for a moment. But as the particle passes by, these atoms quickly return to their normal state. When they do this, they release energy in the form of light. This process is very similar to the sonic boom, like when a jet breaks the sound barrier, but instead of sound, it's light that's being emitted. This light shock wave is what we see as Cherenkov radiation. Now, why is Cherenkov radiation blue? Great question. The reason has to do with something called dispersion. Dispersion is a phenomenon where different colors of light are separated based on their wavelengths. Blue light has a shorter wavelength than red light, so it's emitted more strongly in this scenario. That's why Cherenkov radiation gives off that beautiful airy blue glow instead of any other color. And it's not just a faint glow, it's emitted in a cone-shaped wavefront, similar to the shape of the sonic boom. But where do we actually see Cherenkov radiation in real life? Let's take a look at some of the most common places. One of the most iconic places where Cherenkov is observed is in nuclear reactor. When you look at photos or footage of nuclear reactors, you will often see that glowing blue light surrounding the four rods. That's Cherenkov radiation. What's happening here is that the high energy particles emitted by the nuclear fuel are moving faster than light can in the water used to cool the reactor. This creates that beautiful blue glow that's not just visually stunning, but also incredibly informative for scientists and engineers working in the reactor. Thanks for watching. If you enjoyed this video, don't forget to hit the like button and subscribe for more content like this. Let me know your thoughts in the comments.